6 times 2 plus 2. And what will be the unit? You know that is meters per second. So 12 plus 2, 14. In this particular case, we got the same thing. Not always you will get the same thing. So we got this. Let's say that you want to get the velocity at 1 second. Right? So velocity at 1 second, what will be? The same. So it will be 6 times 1 plus 2. How much will be? 8. And so on. If you want to get the velocity at 3, you get the derivative. I mean, you multiply by 3. So it will be 20. Right? 18 plus 2, 20. That will be the velocity at 3 seconds. Which is 6 times 3 plus 2. That will be 20. Good. Now, the next question I can ask. Find the, I am just talking about the general question. Find the acceleration average between 1 and 3 seconds. So we get the average acceleration. C. Average acceleration. What is average acceleration? By definition.
The change of
Delta
velocity.
V, which is V at 2 minus V at 1 divided by delta T, which is 2. Okay, V at 2. How can I find V at 2? We found it. At 2 seconds, what is V? 14 meters per second. Minus. At 1, 8. Divided by 2. A average is equal 14 minus 8. Oh, divided by 1 because it's between 1 and 2, yes. 1. So what will be, yeah, so 14 minus 8, 6. 6 divided by 1 will be 6 meters per second square. This is my average acceleration. D. Find the instantaneous acceleration. A. At any time. So find the acceleration at any time. Find the function of the acceleration. By definition, what will be instantaneous acceleration? The derivative. What will be the derivative of my velocity function? 6. Derivative of my velocity function is the derivative of this. What will be the derivative of 6t plus 2 divided by dt? So everybody knows that this will be 6 meters per second squared. The meaning is that the acceleration all the time is 6 meters per second squared. Is that correct? All the time. Yeah. Which means that this is uniformly accelerated motion, which is motion at constant acceleration. Right? So that's an example of a motion at constant acceleration. Now, let's say that I can ask, find what will be the maximum gas, what is the minimum position? What is the minimum position? When the velocity is equal to 0. And if we get the velocity equal to 0, what we get? 6t plus 2 equals 0, right? And we get t equal negative 1/3. It's possible. I mean, the time. We get here, and we get, if this is equal to 0, the velocity, so we will get, right? We will get that the velocity is 6t plus 2 equals 0. Negative 2 over 6, negative 1/3. Is possible? No. So there is no place where the velocity is a minimum. So it will be a parabola, right? You know, from here, like this. but there will be times when you can find it. So let's say if I put here negative, and I ask, at what time is the object at rest? So now you will come here, you will get the velocity, which is negative 6t plus 2 equals 0. And you can get the time when the velocity is 0. So I can ask, at what time is the object at rest? What is the meaning that the object is at rest? The velocity is equal to 0. So you need to get the velocity. Once you get the velocity, you can get the time. I can ask, what will be the farther or the maximum position acquired by the object or reached by the object? Maximum position reached by the object.
That would have to be
when the velocity is equal to 0. You get the time, which we have the time already. What is the critical value? In math, that is called critical value in calculus. So the critical value is when we get the derivative and we make the derivative equal to 0. We get the time. We know that the time is 1/3, right? Now, what we do, or what can we do in order to find the maximum position reached, or the minimum position reached, in this case will be maximum. Where we go and plug it in that time. If we are looking for position, maximum position, so you go to the original equation. In math, you did that. You go to the original equation to find what will be the point where is the maximum. And look, I am going to the right, let's say. I am going to the right, like this. When I will get the maximum position. So if I am going like this, when I get the maximum position, what happens when I get the maximum position? Look, this is the maximum position. I stop. I stop because I am turning direction. Since I am turning direction, the velocity has to be equal to 0. Which, how will look this graph? If you graph this, how will it look like? It's an upside down parabola, right? Let's say that it's like this. It's -1, starting at -1. Let's say that it's like this. So at what time you reach the maximum position? What happens when you get the maximum position? This is x. At what point we get the maximum position? At this point, right? And at this point, what is the slope?
0.
So it means that you are turning direction. Your velocity now is positive, and suddenly your velocity is negative. Can you see? So of course you have to get the maximum value. Any question on that? All right, knowing that, I can ask that question. Find the point where the acceleration or where the velocity is 0, or where the object turns direction, which is the same. Those are the type of questions I can ask in the test. And that will be the first free response in the test. I will give a function, and you have to describe the motion from calculus point of view. So I will ask all this type of questions. The first question, free response, will be that. So a question where I give the function and I will ask a different question. All right, so knowing that, I found acceleration. The question can be given in a different way. Now I don't give the acceleration. I can give the function. So the second problem can be, I give the acceleration. Let's say, for instance, that is -2t. I can ask A. So the function is given, and I can tell you that x1, x initial, so you will start from -1. V initial. Let's say that is 3 meters per second. That's it. That's what I'm giving. So this is at 0 time. At 0 time. Initial time. So the question, find A, the change in velocity, between, or the velocity, the change in velocity between time equal 0 and 3 seconds, which is the same because you start at 0 or you start here. So find the change in velocity and find the velocity final at 3 seconds. B, find the position function as a function of time. And find what will be the position at 3 seconds. Same question. Now instead of giving the function of the position, I'm giving the function of the acceleration. So, how can we answer the question? We want to get the change in velocity. We have the acceleration. What did I say that is the physical meaning? If we have a graph A versus T, how can I get the change in velocity? Finding the integral, which is, what is the geometrical sense of the integral? The area under the curve. Can you see there the area painted? So I am asking for that, right? I am asking for delta V. You know that you need to get the integral. So the area under the curve. I go and I said delta V, by definition, is the integral of V dt. This formula is not given in the test. What is given in the test is this and this. So A is dV over dt. How do you know that delta V will be the integral of A dt? You apply the second fundamental theorem of calculus.